Welcome back to section 5 of chapter 9. This section we're going to be looking at functions and their inverses. Now if you think, I think that sounds familiar. I think that we looked at inverses. You would be correct. We saw inverses for the first time at the beginning of chapter 7 when we were looking at exponential functions and then logarithmic functions, which were the inverses of those. There really is not much new today, but there is one little piece that uses what we just learned yesterday. Other than that, it is just kind of a review of what we did then. So, without further ado, let's look to see what we have. Learning targets. I can determine whether the inverse of a function is a function. There'll be a vocab word there. And I can write rules for the inverses of functions. We have done this already. So, let's start out with what are inverses? As a little refresher, in a just general sense, an inverse switches the input and the output. An inverse of a function to get degrees Celsius if we have degrees Fahrenheit would be the one to get degrees Fahrenheit if we have degrees Celsius. It just switches those orders. Being that it switches the input and the output, it switches x and y. That's how we find the inverses. We literally switch x and y. Or graphically, it reflects about the line y equals x, which again switches x and y. So, how can we tell if the inverse will be a function? We do what's called the horizontal line test. Now you're familiar with the vertical line test. That tells you if the graph itself is a function. The horizontal line test tells you if the inverse will be a function. The rules are the same. If it passes through the graph more than once, then no, the inverse will not be a function. If it only hits it once, then yes, the inverse will be a function. So let's take a look at some. Here we have a quadratic. The vertical line test, hey, we only hit it once each time, so it is a function. But then the horizontal line test, we hit it in a couple different places when we draw horizontal lines, which tells us that the inverse will not be a function. Which if we reflect this over the line y equals x, it would be a sideways parabola, which would not be a function. What happens when you do that reflection is the horizontal lines would become vertical lines, and so that's how it works. It's just we don't have to do it in order to do the test. Let's look at another one. Here's a logarithmic graph. Here the vertical line test works. It gets really close to vertical right here, but it is still moving over. So the vertical line test works. So this is a function. Then horizontal line test, we're only hitting it one time each way horizontally. So the inverse is also a function. And how about x cubed? Vertical line test works. Horizontal line test, here it looks like it might get flat, but it is consistently going up. So it's both a function and the inverse is a function. Now a vocab word, if we have both it is a function and its inverse is a function, it's called a one-to-one function, which just means that both the function and its inverse are in fact functions. It also means that each x value goes to exactly one y value, which means it's a function, and each one y value has exactly one x value associated to it. That means the inverse is a function. That's what one-to-one means. If we have an x, we know what the y is. If we have a y, we know what the x was. It would be like a soda machine, right? That's the function where each type of soda has only one button that goes to it. So that's how we can tell if it'll be a function or not. We do a horizontal line test. Next, writing inverses. This is review. To write an inverse, we just switch the x and the y. So if we have an equation, g of x equals x squared minus 9, first thing, we want to change g of x to a y. And then we literally switch the x and the y. So instead of y equals x squared minus 9, we're going to have x equals y squared minus 9. Now we need to solve for y. So we're going to add 9. So we get y squared equals x plus 9. Then we can square root both sides. When we do that, we'll get plus or minus. So y equals plus or minus square root of x plus 9. And then finally, put it back into function notation. We had g of x. So the inverse will be g to the negative 1 of x. This is g inverse of x equals plus or minus square root of x plus 9. Let's look at another one. H of x equals x plus 5 over 8. First step, change the h of x to y. Then we're going to switch the x and the y. And then we need to solve for y. So multiply by 8. We get 8x equals y plus 5. Subtract 5. 8x minus 5 equals y. Then change it back to function notation. H inverse of x equals 8x minus 5. So that's all writing inverses is. We just switch the x and y, and then solve for y. And again, we've done that. That's review. The new part is, how can we tell if two functions are inverses? And this is new because it uses those composite functions that we looked at yesterday. We have a property, a rule that says that if they are inverses, then f of g of x equals x, and g of f of x equals x. Now, I cannot think of one where it'll work for one but not the other, so you really only have to do one of these. And when you do it, if they are inverses, the composite function is just going to collapse down on itself to be x. It's not going to get into any crazy calculations or anything like that. So let's take a look at a couple. Let's use f of x equals 4x minus 12, and g of x equals negative 4x plus 8. Are these two inverses? You might have an answer just by looking at it, but let's try. Let's go f of g of x. So we're going to take our f function, 4 times something minus 12, and we plug in the g of x, that's something. Then we can distribute the 4 to get negative 16x plus 32 minus 12, which you can probably see this is not going to equal x, but let's do the subtraction just in case. Oh, and negative 16x plus 20, not equal to x. So these two are not inverses. All right, see, it just kind of got bigger, didn't stay much, it didn't go down at all. So let's look at another couple. F of x equals square root of 3x, and g of x equals x squared over 3. 4x is greater than or equal to 0. That's just going to make it so that we're only dealing with the positive half of this quadratic. Otherwise, some weird stuff starts happening. That's where we'd need the plus or minus that we had over here. So let's do f of g of x. F is square root of 3 times something. We put the g of x there. Well, 3 and divided by 3, that's going to cancel. Gives us square root of x squared. And square root of x squared is just x. See what I mean by it kind of just collapses down on itself? It undoes itself just step by step in perfect order. When they're inverses, it does that, and these two are in fact inverses. And so, that's what we're doing today. It's largely review, finding inverses. This little bit is new, but that's just because it's what we learned yesterday. And then the horizontal line test is new vocab, but that there's not much to the horizontal line test. So I will see you in class and have a great rest of your day.